Our next speaker is Professor Andrew Shaw, Associate Professor of Physical Chemistry at the University of Exeter and founder of ATTOMARKER Limited. We thank you to Integra Healthcare for sponsoring these afternoon sessions, starting with Professor Shaw, who's presenting on the evolving role of point-of-care testing in prevention and positive intervention in NCDs. Let's welcome Professor Shaw.
Good afternoon, everyone. I think somebody photoshopped that picture of me. It looks much better than it does in the flesh. I'd like to talk this afternoon a bit about point-of-care technology and where I think that will take the diagnostic revolution, a change in healthcare. So I think if we're to understand a lot more about non-communicable diseases, NCDs, we're going to have to make more measurements. We're going to have to make those measurements away from the laboratory. We have to make those measurements when we need them, rather than just when it's convenient for the central laboratory to make them. And so I invented in my research group a new technology, which is now the foundation of ATTOMARKER Limited. And it takes a single blood drop from your finger and then begins to look at many things inside that blood drop. And I'll show you some of those ideas in a moment. But let's look at the blood drop for the moment. There it is on the end of your finger. You should ask, is that big enough? And sometimes it isn't. If you were to sit on the beach with a cup and fill it with water, with seawater, look into the cup, you might conclude there are no fish in the sea. If the sample is too small, then there may be some things in your blood that don't get there. So we started by learning with venous blood, that nice chunk of blood they take out of your arm at the hospital. We started learning and developing the technology, but it works. One of the things in the drop, one of the things the pandemic has told us is the drop of blood is actually really rather good. And we've learned how to analyze what's inside it. Not all things, as I say, there are still some mistakes. The pandemic was important to the evolution of ATTOMARKER because on the day the pandemic lockdown happened in London, on March the 20th, I went to St Thomas's Hospital, drove through the streets of London. It was like a disaster movie. There was nobody there at all, just our car and a few police cars. I was expecting to walk into a zombie or some such coming around the corner. That didn't happen. All the zombies are now left in Downing Street, it would appear. So it's only 2 more prime ministers to Christmas. But we went into the lab, we set up the kit, and the very first measurements we made worked. We were all very close to the computer screen watching that moment of discovery in science. It was really exciting. That's why I'm a scientist. And from that moment, we were beginning to watch people recover from SARS-CoV-2 COVID and also watching them not recover. And before we knew really what was going on, we were beginning to make a contribution. So let's see what we can do for non-communicable diseases, NCDs. We've heard a lot about them today, and we've heard a lot about how pernicious they are, how many people they're going to kill, and whether we can do something about them. There are tests we could do for cardiovascular, there are tests we could do for cancer. The chronic respiratory diseases and the ones I'm going to talk a bit about today are type 2 and type 1 diabetes. The other column on the right-hand side are somewhat less catered for in terms of testing. Rheumatoid arthritis, there are some tests. These are examples of autoimmune diseases, not really communicable, but somehow you start attacking yourself for no good reason, or maybe a good reason we yet don't understand. What about depression, for example? What about cognition? We heard a bit about psychological behavior before the break. Maybe we could measure that. That's a very interesting idea. Maybe we can put proper numbers to the feelings of unwell or feelings of stress. To do that, a finger prick device of some form is going to be important. But where are you going to do this? And this is the list of risk deaths by indications by region. You can see that there are lots of problems in the Western world, and we think we should be able to go to the doctors and get those fixed. The places where you need to make the difference are places like Africa and places like Eastern Mediterranean, where the testing and the healthcare provision is not so very good. If you wanted to go and make a difference into NCD diagnosis and intervention around the world, then you're going to have to go to stranger places. That's also a characteristic, I think, of a new successful technology. The most curious column and cell in this figure is this one here, which says, how do you not know what the alcohol consumption is in a high-income country? That must be something we can count. Maybe it's because when you go to the doctor and the doctor says, how much alcohol do you drink, The correct answer is about average, right? It doesn't say how many units. and I think that's why we don't know. We can't fill in this box. So obesity are problems, behavioral problems, all sorts of factors are things we could begin to address. Is it there? Are these things really there? This study here in Mexico between 2014 and 2018 with nearly 750,000 people revealed that pre-disease and disease condition was discovered in more than 70% of the population. So it's all there, it's happening to us, and yet we don't care about it, it's not on our radar until something happens. It's not there, it's not something we now monitor. Wellness is not something that really happens. So if we put the patient and us, when we're not a patient, at the center of this, just us at home, us in our own normal everyday life, can we make some measurements that might change that? And again, in the pandemic, we've all got used to scraping the back of our nose to get things out of our nose and all sorts of other self-testing. Maybe that psychology, that readiness to self-test, the timing is now for that to be extended. So patient-centered, retention for the control of the person and not just the patient, and we'll see whether these NCDs are something we want to change. My feeling is that some of us will try, and some of us won't bother. Some of us will try a bit more if the doctor could show you the results quickly, and still some people won't bother. But if you can choose, and you're in a position to choose, not just here, but in Uganda, in South Africa, in places where there's no medical diagnostics really, then that's a much better opportunity for the rest of the world. It is really hidden. So looking at the discovery rate in some of these other countries around the Western world, it's extraordinary. But down the right-hand side, Dominican Republic, Cuba, etc., lots of undiagnosed conditions. So the danger is we're all going to do a self-test at home, run back to the hospital, run back to your doctor and say, I've just diagnosed myself with this test, we need to do something. It's going to cause anxiety, and that will need to be managed. Some of the things that need to be changed have got to be the way we treat the numbers, what we do with those numbers later on. So revealing the hidden disease is interesting. Something at the point of care might be very useful. Something at the point of care where you need it, not just in the high-end clinic in the Cayman Island, but somewhere where it's not possible around the rest of the world. So let's identify, let's intervene. And maybe if the blood drop doesn't hurt too much, and it doesn't, maybe you can do a bit more often. Maybe you can use time analysis. You can look at how things evolve in time. That's also quite strange. Usually you just go and get a blood test, maybe get in once a year. That's hardly going to see anything. But if you can do it a bit more frequently, maybe when you need it as well, that's a bit more interesting. So the risk factors, we've heard a bit about these today. Can we measure some of these? If you look at the ones in the right, in this red column here, some of these factors around physical activity, a person's weight and food choice, if you do intervene and it doesn't really work and you've got your weight targets, you're trying every diet that can possibly be presented, where's the reinforcement that it's working? Where's the idea that somehow you're getting better? Not just measuring perhaps how many notches in your belt you're using. So we need to move, I think, healthcare away from break and fix, which is simply something goes wrong, you don't know what it is, you pitch up with the doctor, they make lots of measurements and start talking about your liver, start talking about the way your cardiovascular system is collapsing, there's something wrong with your heart. And at that point, you're full of regret because you wish you'd done something just that fraction earlier. So healthcare now needs to become something that can be more around when you need it, but also around when it's convenient for you, maybe. When it's convenient for you to make a measurement and see at the end of an intervention after a hard run, after an extended dieting period, does that work? So there are lots of surveillance technologies, things on your wrist for measuring your pulse. One of my directors who's massively overweight said his pulse rate was sitting down at 45, and that's probably not true. So it's really important to know that the measurements you're making are accurate, and that's a characteristic of the test that we're doing. What about the hospital at home? Is it possible for the doctor to send you home with a piece of testing technology, and that technology can report to the cloud, and the doctor can see what you're doing? Like that really interesting example from the top of the conference today of the kettle at home, judging whether your elderly father is making tea at normal times. Why do we not make more of the Internet of Things to look at hospital at home? If you have a good answer, Then you can have, to a test, for example, then you can have a teleconsultation that's really founded, I think, in a bit more science, in a bit more diagnosis, a bit more accuracy. What if the first test that you made, the first diagnosis that you made, the first discussion with your doctor was the best one? Make your first best intervention. Then you don't get it wrong, then you don't get the wrong antibiotics, you don't get the wrong drugs, you don't end up in hospital a few days later on. So the best first intervention, and my contribution to this set of diagnostics is going to be some blood testing. Your blood contains lots of things floating around it. There are, of order in a healthy person, something like 380 odd different types of protein floating around in your blood. That's just if you're well and you haven't eaten. Your blood becomes really sticky if you've just eaten something. And these in the trade are called biomarkers. Existing as well is a series of single biomarkers. One thing tells me I've got a disease or not. One thing tells me I've got this disease or not. I also don't think that's true. We need to look at lots of things. We need to look at the fingerprint, and not just the fingerprint now, but we need to look at the fingerprint as it evolves in time. There are markers to tell you how well you're responding to drugs, for example. Companion diagnostics. We should do more of that, to tailor that, to see how things are working. Predictive biomarkers. Are there things that you can measure that tell you that it might go wrong sometime in the future? That's a bit more worrying. Do you really want to know those biomarkers if you really have a predisposition to something going seriously wrong? Maybe, because maybe your game is now not to just increase your lifespan. Lifespan has doubled in the last 100 years. Some people are predicting that, as we heard this morning, you might live to 150 at some point. The critical part is that you have a healthy span, a long health span, where you can do all those wine tasting hobbies that you really wanted before serious immobility or decrepitation takes over. There are safety biomarkers. How much of this drug can I use? What's safe to use? And what about exposure to various parts of our environment, etc.? All those things are important. Diagnostic biomarkers for disease are fairly obvious. Do I have disease X? Do I have disease Y? And then monitoring biomarkers, markers of surveillance. So there's quite a collection, but I think it needs to be a fingerprint. When you commit your crime in paradise, death in paradise, one of my favorite, right? So all I need to complete my visit is a murder from an extraordinary venom from a snake that's not indigenous, for example. When you commit your murder, you leave fingerprints around. The police will look for 16 marks of comparison between the fingerprint found at the crime scene and your fingerprint provided to them at the station. You don't always get those. You always get partial fingerprints as well. And then you need a forensic scientist in court to say, yes, I believe that's a fairly good match. That's your doctor. Because when we measure something, it's not going to be a yes-no. Yes-no medicine doesn't happen. Things are going to evolve in time. The fingerprint will become better in time. So we're going to choose our components carefully. And there's a group of standard tests for many opportunities. What if I add 2 more next to it in a very agile way? Maybe I could have 4 more. Does that improve our diagnostic accuracy? Does that improve our sensitivity and specificity to the disease we're looking at? No, it doesn't. Let's throw those away and keep with the 5 that we have. So moving quickly is important. So prostate cancer is this marker of PSA, a fairly inaccurate test, 70% accurate, triggers all sorts of unnecessary interventions for people that didn't have prostate cancer. If you do it over time, much more interesting. If your PSA is evolving in time, that's somewhat more accurate. So yes, no medicine doesn't work. The only time it really has worked well in the pandemic is, do I have COVID or not? And for some of the time, it wasn't right anyway. Maybe 20% of the time it wasn't right. So yes, no medicine doesn't work. Watching fingerprints evolve in time, that's where I think we can make a contribution. So this is my technology. It is in the laboratory. It's about the size of a large toaster in some way. It can take either venous blood or a finger prick of blood, and the minute it gives you answers in 7 minutes. So that's quite interesting. It's important to me that it's as good as the clinical chemistry laboratory. Actually, for many tests, we're more accurate than the clinical chemistry laboratory. And as a scientist, it's important to me that it's reported in a really standard unit, a proper metric scientifically that everybody around the world could understand. Lots of tests are reported in strange units. They need to be compared. Instruments may give you different answers. So mine needs to be a precise answer, and we standardize it against the NIST standard antibodies from the US. It talks to our central servers, which I've called the human cube. And it must do that because I want the test to be performed by people that aren't laboratory clinical biochemists. It can be done by a nurse. But if you get it wrong, we're not happy with it, the cloud watches what happens and can send back a message saying, no, have another go. Didn't work quite properly. We're not happy with that result. When you're in hospital and they run a clinical chemistry test or a test of any form, somebody will say, yes, it's okay to release. We believe that result. And that's important. That validation process is important. So at the end of the day, in the lab, or in fact in real time, we watch the results from our instruments. The next exciting trick is the handheld version of the instrument. That's an iPhone 6 on the top. It'll work for some of the iPhones above that, not the ones that got much bigger, but the ones with the same form factor. You can take that home. Now when you're doing this at home, if you make a mess of the test, I'm going to send you a message saying, I don't want you to believe that there was something wrong with the measurement. Lots of controls in the instrument tell me it didn't work properly. You can trust the test. Now, if I can do that on your home, surely I can now do this in South Africa. Surely I can do this in Chile. Surely I can do it in some remote community around the world. If I can do that, that's laboratory quality testing in the middle of nowhere. That, I think, for me, is a bit of a change. That's a change in the way we can think about diagnosis. And the person making the blood test doesn't have to be very, very skilled because maybe you then use the phone for the teleconsultation afterwards. I can put some AI on the phone and say, this test result should be interpreted in this way. Here are some possibilities from the way that we've interpreted your blood result. If you're not sure with that, then have a teleconsultation. And the doctor gets a secure transfer of the information to the teleconsultation, and a proper piece of diagnostic science can then go ahead. And I get the cube. Now, it's anonymous. We're going to use blockchain to make sure it doesn't disappear. We're going to make sure that you can then access it when you need it. You can consent to us using it if you want. But I will get some view of the human cube. And that's really interesting. That's really exciting. And that's where I think the technology is going to go. That might make a difference to diagnosis. Looking for different types of fingerprints. We'll see those in the field. So if we aggregate the big data, if we pull it all together, in all big data there must be big noise. So there must be some nonsense that's there. But if there is something for big diagnosis, if there's something about the way we can intervene with people in different territories because of environmental factors, or different types of exercise, even validate certain types of dietary interventions, maybe we can begin to address NCDs. And not just NCDs as well, but if you get sick with bacterial infection with your NCD, that combination must come together. If your NCD requires you to take 11 tablets a day, then is your liver, is your body in exactly the same state? Now that's interesting. Now I'm looking at you as a person where all these measurements need to be, all these factors need to be considered. So the NCD evolves with you and evolves in time. For me, I want to start with looking at the liver. The liver is the master chemist in the body. It does absolutely everything. Massive amounts of synthesis, making proteins. It transports things around. It makes bile for digestion. If you drink too much alcohol, it comes through your liver to get rid of. If you drink caffeine, it comes through your liver to get rid of. Every drug you take is detoxified through your liver. It does everything. It's really important for waste management, absolutely everything. If anything in your life is going to see how bad it's getting, it's going to be your liver. It's going to, you can feel it, as it shows in the picture just around here. Some people can feel it getting fattier, getting lumpier. If it's healthy, it'll work well for you. As you change your lifestyle and you make your choices, this chap's going to feel it. And I think measuring the properties of the liver are going to be something that we could do at home. So non-alcoholic fatty liver disease has a pathway all the way through to an end diagnosis for the liver, where you're going to need a liver transplant. And the early phases of liver degradation are nicely reversible. So if your liver begins to show signs of NAFLD or NASH, at some point you could intervene early enough and then reverse some of this damage or limit it. If you were to know about it, that's really good. What you don't want is to come to the doctor when something is broken and your liver is sitting in this NASH state and we're into serious care, maybe even palliative care if there's no transplant available. The liver tends to get better. We tend to load it up with fat from our diet. There's even some suggestion that a fatty liver then excreting fat from the liver or leaking fat from the liver into the pancreas causes problems with making insulin and diabetes. So maybe it's the cause of that. So the liver is already aware of some of the things that are going wrong with your liver. If it becomes a bit stiff and fibrous, then you're heading on the journey to non-recovery. These are two markers here that we're going to add to our set of panels, our set of tests, that specifically point to identification of cirrhosis. So the test will have a good accuracy, and we'll explore that in a moment, from healthy through to non-reversible and maybe end-point diagnosis. If we can do that in Africa, then they get a really interesting piece of science in the local hospital that wasn't there before. So our new liver function test panel, our new fingerprint, will involve a list of enzymes, which are standardly tested in the laboratory at the moment, as is this one. These two are not really available globally yet, but we're going to put them on the chip because we have spoken to the designers. And HbA1c is a molecule that tells you how sugary your diet was. It adds a sugar molecule to your hemoglobin. If you have too much of that, you've had too much sugar in your diet. All these other enzymes leak out of damaged liver cells. And so they're not really good measures of liver function, and I will come back to that, but they are a measure of liver dysfunction. So it's going to degrade in time. That's the fingerprint. It's not quite 16 points of the fingerprint, but that's the one that we can begin to track in time. We can begin to see how useful this might be in solving the NCDs that we've been talking about. What about hyperglycemia, glucotoxicity? All these things are easy to do in your diet, and they all result in liver cell damage and an increase in these enzymes in your blood. So rising trends of the leaking proteins, the leaking enzymes, are the markers of the evolving and decaying liver. Consequently, falling trends of the same markers are also important. So the trend analysis is the bit that I think is interesting, because we're all different. Normal, for me, is not well defined until you measure it. I'm in the normal range. What does that mean? I could have doubled my liver enzyme leaking and still be within the normal range. But if you know what's normal for me, where I am in that range, then I can see how I'm going to evolve in time. So I think the analysis of us as individuals over time can see these enzymes leaking as a result of liver damage and too much sugar in our diet, and we can see it change. So that is interesting. So here's normal. This is the normal range for, let's say, one of the enzymes here, up here. And as cirrhosis takes over, then the enzyme levels begin to rise. If you've got NAFLD or chronic hepatitis, it's even higher. Alcoholic liver disease here is a much larger trend. All of these are increasing concentrations of the damaged of the enzymes in the liver from the damaged state. So it's a nicely sensitive measure. When we get to here, it's up 10,000 times above normal. So that's a really good measure. So I can see quite a lot of things changing. The other liver enzymes produce now quite a dynamic range in my fingerprint. I can see how it's going to evolve in time. So it's an interesting set of targets. But the magnitude of the dose does not predict the severity. So we might have a low problem, a low-level problem that results in some way for a large increase in the enzyme concentration. So just because you've got lots of it doesn't mean to say that you're actually in a really bad way, but it is a good way. The trend is still important. If you reverse it and start making the liver levels, enzyme levels lower, then you're getting better. So we have on the chip a series of tests that will look really good for understanding what's going on with the liver degradation. So things like diabetes and diabetics here and non-diabetics, you can see the liver enzyme panel has a nice sensitivity on all of them, ALT, AST, GTT, gamma GT, and ALP. They are all going to rise, and that fingerprint is a nice measure of what's going wrong diabetically or getting better diabetically. So that's a very interesting idea. Now we can see that, it's sensitive, it's quite specific as well to the damage to your liver. I'll talk about something shortly that will show you a counterexample, but this is specific to liver function testing in type 2 diabetes. What if you knew that? Let me introduce you to your liver tar. Now, this is, if you knew your liver function, you can Livy can tell you what's going on. So you can collect your data from your steps, for example. You can collect your data from your other healthcare devices. And we'll add in the liver function tests. So now you've got a real piece of chemistry to go next to your 45 beats per minute pulse rate, which is not true. But the chemistry measurement is right. And I've checked it's right, and you've checked it with the cloud to make sure it is right. Your liver app can then understand what's going on. You could take this around with you. So now it's not just about being on your own, being good in your diet. Livy's going to be with you, so that if you do a good week of hard work and you make a measurement afterwards, things will have got better. You will be rewarded, and you may be even gamed. We can play these games. If you play computer games, there's a lot of fun in playing the game. Maybe we can turn the gamification of diabetes and health into something that's important. And I really want to do this with children. Now, my finger prick works really well for children because that's not a blood draw. And why can't I, through the cloud, enable a child in New Zealand to compete with a child in the Cayman Islands to improve their obesity? Why can't I play a liver game internationally with children competing with one another, all tagged against some proper liver function testing? So I think the gamification of health may work for some people and might be useful. And I think especially for children, where technology is going to be there, downloading the app, playing with Papa's phone is always going to be exciting. We can build some features into the app. We've already got to the point where you can scan a barcode on a packet of crisps, and Livy gives you a scowl because it's got too many calories in it, too much fat in it, and would give you some nudge not to eat it. Imagine I could extend that to allergy. What if there was a profile on this barcode that said, actually, there's some bits and pieces in here to which you might be allergic. Consider eating something else. That's also interesting, and we'll come back to that as another NCD that doesn't really make the list, or the usual list, but it's now a rising problem. That's food allergy. So I think the game, the app, somebody with you, some AI with you all the time, might help you to make a proper change, even make a reversibility of a serious condition. So, combining serial measurements over time, changing of lifestyles, doing the hard lines, doing the gym every week, and the liver tells you you're making progress, keeps you on the straight and narrow. I think that's going to be interesting. And we'll have the liver test out with the handheld device next year for preliminary trials while we work up the game. But Gamma GT is a little more detail here. Gamma GT is the one that's telling you you're drinking too much. This is 40% above normal levels from too much alcohol. It will tell you that you've had a busy weekend. It will tell you you've had a good Christmas. And maybe you know that, but then maybe you can work hard to get it to come back again. So again, Livy will be there telling you that things have not gone well. The proper measurement has told you that you can reverse these processes. Gamma GT will come down very nicely if you stay off the booze for a bit. So these things are interesting ways of looking at how we might tackle the NCD problem. Weight loss and LFT changes work really well. So these are deltas. These are 40%, 50% changes in these combinations. The entire fingerprint moves down as you begin to lose weight, and decreases by 50-odd% or so for some of the enzymes. But together, it's a nice, sensitive, and specific measure to some of those activities that you're changing in your life that might make a difference to the way your liver is responding. You can see how I could do this for the heart, or you can see how I could do this with other organs like your kidneys. I'm starting with the liver because of all the traffic, all the life goes through into the blood, goes through into your liver for detoxification, for example. So it's possible, and it's been shown in this trial in the direct trial in Edinburgh, that you can put your type 2 diabetes into remission. You can turn it round. So when you're in a clinical trial, not with my device yet, but when you're in a clinical trial, measuring those enzymes, and with the doctors watching you all the time, the patients get better. They go out of type 2 diabetes, they lose their type 2 diabetes, technically into remission. The moment they come off the trial, nobody's watching them, no measurements are being made, type 2 diabetes comes back. So now I think if we can show that it works under clinical trial conditions, and we can continue to monitor potentially all the time, even if it's just a doctor taking a measurement for you when you go to the doctors for a routine checkup and saying it's going wrong, that might be sufficient to nudge you into making a change. So we can reverse type 2 diabetes. And hopefully with my technology, not just here in your clinic, but everywhere in some of those countries where those numbers are really rather big, and we'd like to try and solve the global problem as well. But I was talking about the liver functions being measures of standard liver function tests. They're called LFTs. And they actually only measure liver leakage. They don't measure real function. One I really like is your caffeine half-life. So this tells you, when you drink a cup of coffee, the caffeine gets out of your stomach into your bloodstream. How long does it last in your bloodstream? For how long do you get the hit? And the liver's job is to take the caffeine out and make it go away, preferably before you go to bed. And it will take it out at a rate, a half-life. It will take out half the caffeine, in the case of this study here, every 6 hours. But the liver half-life varies between 2 hours and 9 hours. So do you have a 2-hour liver, or do you have a 9-hour liver? Do you take 2 double espressos just before you go to bed and it doesn't matter at all? Or do you walk through the kitchen when your wife is drinking one and you're awake all night because the caffeine has got into your bloodstream somehow? So the liver's ability to metabolize caffeine is a measure of liver function. Now, that's not measured routinely. It's hard to measure, and we need better biomarkers actually of real liver function. But the key to this experiment that I like so much as a demonstration is if you take a drug, and this is a drug, it's a serotonin inhibitor, it's a fairly large, fairly widespread use drug in depression. We're in polypharmacy. As I said earlier, some people are taking 11 drugs a day, some people are taking 5 drugs a day. They're all coming through your liver for changes, for clearing it, to get rid of it from your body. It's technically a toxin. And that's going to change your liver half-life. That's going to change the way your liver works. We don't know. Honestly, when you put 11 different types of drugs in possible combinations together, what they do to the function of your liver. So if we can find proper measures for the liver function, the actual liver's ability to do its job, then we can see how things like polypharmacy can be managed personally. That's the important bit. A 2-hour liver or a 9-hour liver, maybe you can tolerate a bigger dose. That would be good to know. If it's a 2-hour liver, maybe you need a smaller dose. There's one confounding problem here, and this is measuring the burn. So those enzymes that are made in the liver, that leak from the liver, also are leaked from your muscles when you work out really hard. And so if you go to the gym, you will end up with a larger increase of these enzymes in your blood, and that will go back down to normal levels after a few days. So you can measure the burn. Maybe that's good for athletics, maybe that's good for people that are really dynamic in their exercise, and I can see a nice niche market for all the gym junkies that are going there all the time, showing how hard they're changing their body and how hard they're working things. But that confuses my diagnosis, right? So this is an example of you'd see a big rise in liver function associated with having been to the gym. Arguably, you don't have fatty liver disease if you've been to the gym, but nevertheless, that's the way you can see how a diagnostic test might get fooled by something that's fairly important. Time gets you back on your side, though, because it goes back to normal, and then we can look at your liver disease again. So measuring the burn is a bit of a counter. It's a huge problem, these NCDs, a massive problem. 41 million people each year, equivalent to 74% of all deaths globally, are responsible with NCDs. We all get other things on top of our NCDs, and if there's one thing that the pandemic is learning us, or the endemic is now teaching us rather, is that we're going to have potentially COVID frequently on top of our NCD. We're going to have the flu on top of our NCD. All these different recovery profiles are all related to the way our liver works. But the stat that I like to put alongside that is there are 107 mobile phone contracts per 100 people in the world. So they're going to have enough power. This thing in our pocket has enough power now to make my measurement. It just needs the camera and some clever nanotechnology in our chips. And then the phone can think about what it means in the short term, isolated from the cloud, and with real help and the full power of big diagnosis sitting in the human cube of data above it. So actually, this, even in Africa, where they've missed out laying copper cables for telephone lines and put in mobile phone cables, mobile phone distribution masts, everybody can then have a mobile phone, or is heading towards access to mobile phone technology, and therefore mobile computing, teleconsultation, and a new paradigm, I think, in healthcare. So this could be really important, and then we can concentrate on things like health span rather than just lifespan. We want to live for longer to do all the things that we want to do. in a healthy way, managing or keeping at bay the things that are going to be terrible for us. There's some revolutions needed, and I did a clinical trial with a colleague of mine who was a colorectal surgeon, and I got this back at me. Andrew, you've got to treat the patient, not the number. You're a scientist, I know better because I'm a medic. So we were doing a trial for post-operative recovery, and we were looking at standard marker of post-operative recovery, C-reactive protein. It goes up when the knife goes in, and then if you get better, it comes back down again in a fairly known way. And I started doing some sums. Now, I could do the sums because we were making frequent measurements. Because the blood drop was taken and not a big blood draw, the patients were happy to have frequent measurements. So even over the time course of the 2 or 3 days post-operatively, I can take frequent samples every 8 hours or so. CRP doubles every 8 hours and halves every 19 hours. So you can work out whether it's going down, whether the CRP level is telling you the underlying acute phase response, the ouch from your body was going up or down. And so I was looking at this patient in bed 4 and got hold of my surgeon colleague and said, Mr. Surgeon, I think there's something wrong with the patient in bed 4. And he said, no, the patient wanted to go home. They were feeling good. They thought they would recover better whilst being at home. And the CRP levels not very high, and we think they're coming down. I said, no, my new sums look really quite important, and you should give it a go. Andrew, you've got to treat the patient and not the number. So that's what happened. They were discharged, and then they were readmitted 2 days later on with a screaming C-reactive protein. They'd had a cut and shut in their bowel, and it had basically opened up and leaked into their body. They had sepsis. They were in hospital for a seriously long time, very unwell, and they got no remuneration for the hospital for getting that. So sometimes the number's going to work, and I will make sure the number's available for the doctor to dismiss and maybe and treat the patient, not the number, was the right call sometimes. But it's got to be there. Also, the doctor's now going to have you walking into the surgery with one of my devices saying, hey, look, my liver function tests are looking a bit strange, or my liver function test changed. Doctors are getting bombarded all the time. Dr. Google is a big problem for them. Patients are walking out with having printed out the entire internet of something on their disease state that they've been diagnosed. And sometimes Dr. Google is better. One of the things I think is interesting is if I'm putting lots of information in my fingerprint at the doctor, how much information can I usefully give the doctor before it becomes too much? I've just seen too many dimensions, too many possibilities. So the doctor may need ultimately some support with AI, lots of information, look at comparisons. The cube has everything in it. AI can do the thinking. Hey, Mr. Surgeon, we think there's an acute phase rise here. Please think about keeping the patient in for another 8 hours. Run a quick test before discharge. Wouldn't you want the discharge test now? Do a CRP in 7 minutes before leaving the ward, and then you go, oh, actually, maybe we can save an awful lot of pain from this sepsis case. So where else? You've got your NCD, you're living with your NCD, and you're hopefully trying to manage it. And what else can you do that we can do on top of that? And what's personalized? What can we take from the philosophy of measurement, routine personal measurements, into changing the way that we manage other diseases? And so I'm looking at quite a lot of things. HIV testing in Africa could now be done. So a triple antibody test done fully quantitatively could be done as part of a series of investigations. I could put HIV alongside malaria testing or alongside dengue fever testing, for example. I think allergy is a thing now. We're getting allergic to our food. Why are we getting allergic to our food? That doesn't make very good evolutionary sense, but we are. About 6 to 10% of children have got some sort of food allergy of some form. So we're going to do some allergy testing. We've got some of that in the clinic at the moment. But what about indoor allergies, living in this hygienic environment that we're living in? What about outdoor allergies where somehow we can't walk through fields without sneezing? Where do they come from? What are the origins of these allergies? We don't know where allergy comes from. It's very complex. But again, with enough data collected and globalized, maybe big data and big diagnosis can help with that. Women's health and fertility, I'll come back to that in a moment. What about an immediate profile of somebody when they arrive in casualty? I took my little boy to casualty. He'd had a fever for a few hours. Mum was a bit upset about it, so we took him in. The triage nurse put a thermometer in his ear, said his temperature was 35 degrees, and I said, no, it isn't. And the doctor said, probably not, go and wait for a couple of hours and we'll see what. So my initial triage was obviously wrong, and my child could have deteriorated. He didn't. He woke up, he broke the fever, and we were out within a couple of hours because he didn't need anything. But you get all these horror stories of babies presenting, and they're not sure what's wrong with it. The small volume heel prick might tell you they have a screaming CRP, might tell you they've got a whole series of septic markers. So I think those are interesting opportunities where you need the answer now. It's really important to have the answer where you need it. Food allergy is on the way out, so we are in final stage testing for food allergy now with these markers. These are top 8 food allergens. And so you can get a finger prick test. You can find out those markers that are in high sufficient concentration to point towards anaphylaxis. You can get some markers in your blood that point towards protection from food allergy, and you can do that in a single consultation. We recommend at the moment you do that with the immunologist because allergy is complex. But the answers will be there. And again, we can see how things like desensitization diets, eating a little bit of peanut every now and again, might improve the protective levels, IgG levels in your blood, improve your protective fingerprint. So we can begin to do that, and we can begin to address what is an NCD that's not on the list that I mentioned at the beginning. This is what it looks like. So there are 22 components in this profile. This has got a known peanut allergy, and often what happens now is that you arrive following some peanut event, something as dangerous as anaphylaxis maybe something just like swollen in your lips, and somebody does a test for peanut allergy. Because they're done one at a time at the moment in the laboratory, that's the result you get. You can confirm your peanut allergy and begin to start therapy for it if possible. But actually, this patient here had a bit of a problem with hazelnut, something with cashew nuts, and something around wheat that was rather interesting they didn't know about. So now you have this allergy profile. Was it a problem with the peanut in something that had wheat with it as well? Was it a problem with it being peanut butter, for example, or some peanut sandwich they'd eaten? Does allergy add up? Now, concentration of IgG doesn't point towards severity, so these just don't add up to make a result that's 3 times bigger. But now you know. So this is not just saying, oh, the history told me the patient had peanut, I did a peanut test, and they did a presumptive test, and they did have peanut problems. This is about having a look-see. Again, available in 7 minutes. Add the other test on to give you the protective layer in 15 minutes. That's changing. That's progress. Actually, not much point taking this to Africa because food allergy is hardly known at all in Africa. It's just not there. It's a very first world problem. This is an area where I think we can make a big difference. So the baby girl starts doing a menstrual cycle in the womb. It's an amazing piece of synchronous chemistry that's going up and down. And then, of course, there are lots of people that want to try and have children, want to coordinate those processes, want to understand their menstrual cycle. And so the girls have this menstrual cycle that's going up and down. It changes in frequency a bit. It changes, and sometimes it's a bit late, sometimes it's a bit early. What are the factors that change that? Can we measure cortisone? Can we measure other factors of stress in your lifestyle? Can you measure your liver function? Can you measure the impact of a new drug on your liver? Does that affect the rate at which the liver removes estrogen from the bloodstream, and so the period cycle? Can we understand a bit more about that? Let's measure that. Let's measure it when you're well, and let's see what happens when you're feeling unwell, and see whether these things are related somehow. They must be. These are complex, dynamic chemical systems, and they're going to be sensitive to all sorts of things, especially later on in life when the menstrual cycle collapses and you go into menopause. What is the right dose of you personally to have hormone replacement therapy so that that cycle peters out gently without so much stress? That's going to depend in part on your liver, because you may be taking other drugs, you may be having a fatty liver as well. So now we get to superpose these 2 major systems in the body to understand a bit more about this. This, I think, will be really important. We'll bring this out as soon as we can, probably in a couple of years. This is an example of a marker. This did make my list of non-NCDs at the top. This is an example of a biomarker that you really need to know now, not 3 weeks later on when you can get the appointment with the doctor and say, I was a bit depressed and this is what it felt like. Wouldn't it be really good if you could measure it? There's some great theories around the inflamed brain. There are some great candidate biomarkers, but then you get problems like the American side of the Atlantic and the European side of the Atlantic don't agree on what depression means. So we're going to have real trouble working out whether the biomarkers diagnose depression accurately. So I think we need to try lots of panels. We need to look at biomarkers for mental health. But now, could you in the moment of depression, make a quick finger prick test and see whether you've got your markers of depression elevated or down? Did the drug work? It affected your liver. We've just seen how it might have affected your liver. But did the drug make you feel better? Does it correlate with something that went up or down with the biomarkers of mental health? It's way back in the research laboratory, but I think we should bring this out quickly. It's got to be the subject of a large trial base, but let's try. And we can do it when you need it. Go straight back up into the cloud, and we can begin to do maybe even a big cohort study, 1,000 people, 10,000 people, to understand how these biomarkers work. Voluntarily sending you a chip home if you happen to own one of my devices. Really interesting idea. If you're a bit depressed, maybe you shouldn't be pricking your finger. Maybe that's a bit too much of a challenge. And the area I'd like to get into is to see whether we could understand biomarkers from saliva. So maybe if you are depressed, sucking a lolly, putting it in the instrument, that's a much lower level interaction. Much better for babies, much better even for animals. The problem is, we slobber a lot, somewhere between 0.5 and 1.5 litres of saliva every day. So if I take a measurement from your mouth and your CRP level was 80, if you're in a high slobbering phase, that's going to just dilute it. It'll be a number that's reading 30. Suddenly my fingerprint depends on how thirsty you are. My fingerprint depends on how hungry you are. It's all over the place. If I can fix that, and I've got some ideas, if I can fix that, then saliva has some real advantages in non-invasive biomarker testing. And then the at-home testing really works. It will be simply sucking on a lolly that has a little encouragement on it, not sugar, but something that changes color maybe, just a bit of excitement. Squeeze the lolly into the chip, and then you get a proper measurement. Saliva must come. This dilution problem has got to be overcome, but I think we can do it. There are some ideas there that will work. And then it will work in the chip. I've already broken the saliva matrix for measuring the SARS-CoV-2 antigen, so I know how to do the chemistry. I just know how to work out the dilution factor. So saliva is going to be interesting. Companion diagnostics for chemotherapy. This is an immunotherapy molecule you get given to keep your CRP level down. Here it is. It's working in this patient. Nice high concentration in their bloodstream. No inflammation. Really nice. Working properly. All these other patients here, really high concentrations of the drug. It's no longer working. They've got used to the drug. They've rejected the drug. They've mounted an immune response to the drug. And so put the companion together. You can do this at home. Optimize the dose. Report the number in. AI can watch it for you and then tell the doctor when something goes wrong. Lots of interesting ideas in companion diagnostics. We've got COVID with us at the moment, and that means COVID and fatty liver disease, COVID and the flu, COVID and bacterial infections are going to happen, and we have a problem with antibiotics. We have a real problem with the bugs working out how to get around the antibiotic, and they're not effective. There are some cases in Birmingham in the UK recently where gonorrhea no longer responds to basic antibiotics. If we measure something early, such as CRP, and this is a reasonable measure of what's going on, but you can also put some other factors alongside it. So this is a patient that arguably might have the flu, but not with a CRP level that high. That's quite suspiciously wrong. So the flu and a bacterial infection, you don't want to be sent home saying it's the flu, come back in 2 days, when you're about to develop bacterial pneumonia. So I think getting a test in front of, a well-informed test in front of every antibiotic prescription is really important. This little guy, the handheld device, is one of the 4 leading technologies for the Longitude Prize in the UK, and they asked us to put it on permanent exhibition in the Science Museum. So if you go to the Science Museum in London, you can be able to see this in the new Welcome Medical galleries on display there. My son has to go 14 times a year. So better information in these complex scenarios, a precision understanding about what's going on, identifying patient groups, understanding critical intervention areas, speed of the diagnosis, lots of opportunity for point of care. Short-lived, we can learn diseases that may be short-lived, NCDs that are going to be around, can we train those out of you? What can we do, for example, with this thing that's around us at the moment, COVID? I'm a bit positive about the pandemic at the moment. It looks like it's stuck in this Omicron hole. Omicron is not really the son or the daughter of Delta or the son of Beta. It jumped to Omicron. and it now looks like it's stuck down the Omicron hole. If it stays there, we may be in with a chance of this becoming a winter flu. But we made some measurements, and you can look at people's profiles, and we can look at lots of them. So I measured vaccine responses to the Wuhan, that's the initial escape version, but alpha, beta, gamma, delta, and all these other Omicron variants. And for some patients, and this is why I'm quite excited, they have protection over all variants that I've measured so far. And 75% of people have this universal response. That's really exciting because it means that we're all going to be protected. If we keep the antibody levels up, we might have got this guy in a corner. Some people, about 25% of them, have gaps in their immunity profile. They need to know that. We need to fix it. But if you don't make the measurement, then you don't know these things. So we've been testing COVID testing here in Cayman at Integra for a while, and so I can show you the immunity profile of the Cayman Islands from 475 tests. And this is the response of antibodies to the spike protein. That's the sticky out bit at the top of the virus that we need to raid antibodies to be protective. And this tells me that something like the response of antibodies from less than 10% of the initial vaccine is now left in the Cayman population. So you've only got 10% of antibodies left, which means, and this, about a third of people here are way below that. So when BQ1 comes off the boat next week, and it's likely to, quite a few Caymanians are walking around with hardly any antibody protection. So now you can go next door and get the Moderna jab, which is bivalent. This is the response to Omicron. It's even worse, right? So this threshold here, even fewer antibodies above the threshold that I think will be protective. So there is a chance now, if we can keep the antibodies levels high, if the virus sticks in Omicron, then maybe we can keep it as a cold. What I don't think we want is all this viral DNA being acquired by our own DNA, sitting there as a legacy to our COVID infections. Some people think that the Black Death viral DNA sitting in our genome causes autoimmune diseases. This is a novel paper that came out just last week. So, Cayman immunity, go and have your vaccine next door. Don't see why you wouldn't do that, because you can see a cruise ship every day with the new variant for you. The reason I get excited about this is the human cube. Not only can I tell you that the test was done properly, it's a good quality number, and that number is as good in sub-Saharan Africa as it is in the Cayman Islands, as it is in London. That's really important for the fidelity of the measurements. But now I can begin to put these ideas together. If it's there in blockchain, it's not going to disappear. If it's there in blockchain, you can agree for it to be released for me to do some science with and work out what the human condition is. How does NCD and COVID infection change? What happens to your liver function when you've had COVID 3 times? What if we could make those measurements really quickly? What if I get the handheld device out there into 10,000 people's hands, and they all do a test in one day? 10,000 data points on one day, the biggest clinical trial ever performed every day. That's a really nice idea to point towards NCDs and COVID infection, NCDs and flu infection, flu and COVID together against big drug cocktails. So I think the human cube actually changes the way we do things and makes big diagnosis a big opportunity. So let's change healthcare from break and fix to wellness monitoring. Let's have a look at what's going on. Let's intervene early. Let's make some lifestyle management changes. Measure the benefit of the changes against some real pieces of chemistry that says, yes, my liver's getting better because I measured it properly. And then we can see where some of these other AI learning opportunities work. And this book here by Tom Lowry, who's a bit of a futurologist at Microsoft, has some of these AI promises in it. It's not all there yet. AI has got to learn, and that's quite hard. But we could address health span, we can address lifespan, and quality life. So those changes are going to be really interesting, and I think with the right measurements, we can move to what could be the beginnings of a new healthcare revolution. So I hope that was an interesting idea. Let's see whether my technology goes somewhere, and you'll see it here in Cayman pretty quickly.